Now we're going to work on Descartes' rule of signs. So what is that? It's basically a rule that helps you find the number of positive, negative, and imaginary solutions inside your equation. So here we go. We have this huge solution. So how can we find the number of positive solutions? So let's just put positive, negative, and of course imaginary. So for positives, we just look at the changes in the signs and we do off of that just from here. So basically, if we look here, this starts off as a positive, 2x to the 6th. That is a positive because it doesn't have a negative in front of it. And it changes to negative 3x. So from the positive, so basically it's positive and it goes to negative. So that's one change. However, it goes from negative to negative again right here, as you can see. So it just stays there. And does it change in the next one? Yes. From negative 5x to the 4th, it goes to positive 9x to the 3rd. So there's your second change. And here it goes from positive to positive again. So that's just a positive. Then it goes from positive to negative 4x. So that's 3. And then from negative 4x, it goes to positive 8. So 4. So basically, from here, we have 4 positive solutions. And now we look at our degree here. So since our highest degree states that it's 6, so that means we have 6 solutions, whether they be negative, positive, or imaginary. So how do we find the negative solutions? Well, to do that, we have to plug in negative x instead of x. All right, so basically to find the negative solutions, we have to plug in negative x instead of x. So let's go through this quickly. If the power is even, the negative x is going to become a positive x. So if it becomes a positive x, it's going to become the same thing. Since that's positive x, 2x to the 6th. You get it? Negative x to the 5th. If the power's an odd, then it's going to stay the same. It's going to be a negative x. So negative x times negative 3 is going to make it a positive 3. Over here, negative x to the 4th, even term. So it's going to become a positive x. And when it becomes a positive x, it stays the same. So it's just going to be negative 5x to the 4th. So basically what this is, if the power is an even, then it's just going to stay the same, like right here. But if it's an odd, the negative x stays as negative x. So that means the negative x has to multiply by the coefficient, and that switches to a positive or the other term. So over here, let's go. Negative x to the cubed. I'm sorry for the background. It's kind of... But yeah, negative x cubed, it stays in negative x, so that becomes negative 9x cubed instead of the top one. And 7, negative x squared. This is a good example. Negative x squared is x. So it's right here in this case, it's going to stay the same since it's an even. You see? Pretty simple, right? And then here, negative 4 times negative x. Basically, there's a 1 there as an exponent, just hiding. So it stays the same. This just proves the point. Odd powers, keep them the same, negative x, and then it switches. Instead of negative 4x, it's going to be positive 4x. And then the 8 stays there. So now what you do with all of these, and now you look at the changes like we did at the top. And that's the number of negative solutions. So over here, it goes through, it's basically a positive at the front, positive, positive. That's not a change. Positive, negative, that's a change. That's one change. And then negative to negative, no change. And then negative to positive, there's a change. 2 changes. And then here, it doesn't change, they're all positives, so it doesn't change. And as you can see, there's two negative solutions. And now you add these up, you get 6, which is the highest degree. So these are all of the solutions. There's no, in this case, there's no imaginary solution. But what you could do now, alright, so I got a new sheet of paper, and here we are. We got 4 positive, 2 negatives. So since the highest degree is 6, our total is 6. So all of these have to add up to 6 because you have 6. That's the highest possible number of solutions you can have. So it's 4, 2, 0. However, it's not always this case. The negative always stays the same. However, I wrote this 2 here because you always go down to from the positive if you can. So since this 4, there can also be 2 positive solutions. And the negatives always stay the same. So since there's 2 negative solutions, it's always going to become 2 negative solutions. So here it's 4. But you can go down 2. And then the positive solutions can be 2. And then now look, the total still has to be 6, right? So 2 plus 2, that's 4. But we need 6. The total is 6. So there would be also 2 imaginary solutions. So this just shows there's 2 scenarios that could happen. There could either be 4 positive solutions and 2 negative solutions, totaling the 6, the highest degree. That's the number of total solutions. Or there could be 2 positive, 2 negative, and 2 imaginary. So here's another example of a problem. We did all of that, and now let's see. So Descartes' rule again is finding out how many positive, negative, and imaginary scenario solutions there could be. So over here, what do we do for positive? We see the changes for the positive x. So here's a change. It's basically a positive, negative. It goes to negative, that's a change. Negative to negative, no change. However, negative to positive, that's a change. And then here, positive to negative, that's another change. So we got 3 changes, so that means there's 3 positives. So I just kind of wrote out the negatives. So now we're looking at the negative solutions, so we must plug in negative x instead of x. So let's get right to it. Whoa. Anyways, negative x to the 4th. The even power says that the negative x becomes a positive x. So it's just x to the 4th. And odd, so the negative x stays as negative x. And then negative 3 and the negative x become a positive. It causes the negative 3x to become a positive 3x. It changes. If the odd powers change it, the sign, even powers don't. Okay. Even side, it stays the same, negative 10x squared. Basically an odd sign, since it's an exponent of 1, so, this too, negative 8x, it changes, it's odd, basically. Negative 8 times negative x, that's pretty simple. And then negative 16. So there you go. We got the negative part. So now, here we go. The changes. It's positive from positive, so that's 0. And positive to negative, that becomes 1. And then here it's just negative, negative, negative. So it stays at 1. So let's look here. The highest degree is 4, right? So that means there's a total of 4 solutions. So look, 3 plus 1 is already 4, so there can't be any imaginary solutions. However, when we go into our second scenario, what else could happen? Well, we can go down 2, so we could also have 1 possible solution. And as I said before, negative solutions always stay the same, so it's always going to be 1 negative solution. However, the positive changes, so it could also be 1 positive. And then as for imaginary, do the math. The total is 4 solutions because of that highest degree. So 1 plus 1 is 2. How many more? 2 plus y is 4. 2 imaginary solutions. And there you go. That's Descartes' rule of signs. Really easy. I mean, I'm holding my phone while I'm doing this, so I'm sorry if the camera moves. But here are the two cases. I mean, you can cross that out now. That's just to help. You could either have 3 positive solutions, 1 negative solution, and 0 imaginary. Or you could have 1 positive solution, 1 negative solution, and 2 imaginaries. So there you go. Descartes' rule. And thank you for watching.